Hi folks, just continuing our work on differentiation. So far we've looked at differentiation by first principles. However, in general, we'd rather, if we can just write down the derivative, we'd rather do that than go through the process of the first principles. So the next step in differentiation is to look at the different types of differentiation we can come across, our different rules for differentiation. The first one we're looking at, as you can see, is the chain rule. Now, chain rule, you've already met it higher, so this is just a bit of a recap really. The chain rule was used in situations where we have composite functions. In the case, let's say I have some function k of x is equal to composite functions f of g of x, so a function of a function. If I want to work out the derivative, so k dashed of x, then what I would do is apply the chain rule in this case if it's a function of a function. And the way we do that is we differentiate the outer function first, so the f is the outer function, so we do f dashed of whatever is inside f, and then we multiply by the derivative of the inner function, in this case g dashed of x. And we could extend this if we had multiple more functions, so f of g of h of x, for instance. Again, you would start on the outside function and then work your way, multiply by the inner derivatives as you go along. Work outside and work your way in. So just a wee example where you might see this, and you'll see some examples in a wee second as well, but k of x, let's say, is equal to 2x plus 1 all to the power 3. So in this case, this is a composite function, our inner function, which we'll call g of x. I'll just do this in green. So if g of x would be our inner function, 2x plus 1, and then our outer function would be f of x, which is something cubed, so x cubed. Okay, so to differentiate that, using the chain rule, k dashed of x, we'd say differentiate the outer function. Remember, this is the something cubed. In this case, we called it f of x, something cubed. So we differentiate that first. So to differentiate something cubed, we bring the power down the front. So 3, instead of 3x, so this inner function still stays there. So this g of x inside is still g of x, so f dashed of g of x. So 3 g of x squared, subtract 1 from the power. And then we multiply by the derivative of the inner function. So we look at this 2x plus 1, we differentiate it and multiply it. So in this case, 2x plus 1 just becomes 2, so multiplied by 2. And in a lot of cases, you can then simplify this, so 2 times 3 is 6. So we get 6, 2x plus 1 squared. Okay, and that's the chain rule. So again, used in situations where we have composite functions. Now what we'll do is a few examples. These are all in your notes, so you can just follow along, maybe even try them before you see me do them, just to make sure you get your kind of understanding what's going on. But this is your first example, and where we have f of x is equal to 3 minus 2x cubed. So very similar to the one we just had. So in this case, applying the chain rule, f dashed of x, so our outer function is this something cubed, and our inner function is 3 minus 2x. So we differentiate the outer function, 3, bring the 3 down the front, 3 minus 2x, and drop 1 from the power, squared. And then we multiply by the derivative of the inner function, which is in there. So the derivative of that is just negative 2, and what we'll do, just to make sure I don't confuse myself, put the negative 2 in a bracket, because it's multiplying negative 2. Negative 2 times 3 is negative 6, just simplify them at the front, and then we end up with that. Okay, so again, that's something you could be asked in higher as well. So part B, f of x is equal to x squared plus 3x, and that's all to the power 5. Again, just have a wee look at it, make sure you understand what is the outside function and what is the inner function. In this case, again, it's all to the power 5, so the power 5 is the outside function. So f dashed of x, applying the chain rule, bring the 5 down the front, and subtract 1 from the power, to the power 4, and then multiply by the derivative of the inner function. In this case, it's a wee bit trickier because we have two things that will differentiate and give us a non-zero answer. So in this case, this becomes 2x and plus 3. There we go. And that's fine for your differentiation. If there's not really anything I can do to simplify that. The only thing I could maybe do is I'll maybe bring the simpler bracket out the front just to make it look nicer, but I mean we've done the differentiation here. X squared plus 3x to the power 4. Okay. So again, just following on your notes, part C, so f of x is equal to the square root of 4 minus x cubed. Now, as we know from differentiation last year, I really want to write my functions in a form that are easy to see how to differentiate it. So in this case, I'll convert my root here into a power a half, and then 4 minus x cubed inside. Okay, and then we can see very similar to the first two examples, we have something to a power, all to a power. So to go ahead and differentiate that, just bear in mind that's not a dash, that's just a pen mistake. So f dashed of x is equal to, bring the half down the front, so a half, 4 minus x cubed, minus 1 from the power, so negative a half, and then multiply by the derivative of the inner. So in this case, the 4 just disappears when you differentiate it, but that becomes negative 3x squared. So get that, and then I can make that just a bit simpler. So I'll bring the 3x squared out to the front, so negative 3x squared over 2. That's just kind of preference at this point, what way you want to write it, to the negative a half. And then what I could do is bring that down the bottom and make it a root as well, just to make it all nice and contained within the one fraction. So negative 3x squared all over, and then I have 2, and then the square root, because that's become a positive power now, minus x cubed. There we go. Okay. So continuing on, f of x, part D, f of x is equal to cos 2x. Okay, so again, some of them are, you may take a couple of seconds to notice that they are actually composite functions. In this case, the outer function is the cosine, and then the inner function is the 2x. So what we want to do first is differentiate the outer function, the cos part, and then differentiate the inner part. And we had a formula for this last year anyway in higher, so hopefully it's familiar to you. But we will just do it using the process that we've looked at already today. So differentiate the outer part. So when we differentiate cosine, we get negative sine 2x. But then we want to multiply that by the derivative of the 2x, which is 2. And if you do remember your formula from higher last year, that's what we get anyway. That was on your formula list, negative 2 sine 2x. Okay. So moving on, so this is part E. This time we have a trig function to a power, so sine, oops, I should have f of x equals there. Okay, right, so in this case, this is just a bit your notation for your trig functions, and not the best notation, but we can rewrite this to make it a bit clearer. So if I was to write this as f of x equals, remember sine to the power 4x actually means sine x all to the power 4. So what I might do here is just make this really clear, make it like that. And then it becomes clear the outer function is the power 4, inner function is sine x. So the way we go ahead and differentiate that is we differentiate the power 4 first, so 4 sine x to the power 3, remove 1 from the power, and then we multiply by the derivative of the inner part, which sine x just becomes cos x. Okay, and that's us there, but I'll just bring the cos x to the front. I just like writing my trickier brackets at the end. So sine x to the power 3, or you sine cubed x if you like. Maybe I've written that. And then just bear in mind that there's a couple of things you could do with this as well, depending on like what the question's asking you to do just in future. But I could end up with like 4 if I write my cos x sine cube x like that. Something like 2 sine x cos x is just sine 2x, so I could have something like 4, bring one of the sine x's out of that cube, cos x, and then sine squared x. This is just a wee bit of extension for later on when we do a bit of like integration with trig and so on. Just nice to remember our trig identities. And then 4 sin x cos x is 2 times sine 2x sine squared x. So I've got a few different ways we could manipulate this if we wanted to, just so you can see it. But again, don't need to worry about the red bit right now, just for in with a wee bit of interest. So part F, then continue with the chain rule. So f of x this time is equal to cos of x squared plus 5. Now, again, looking at the chain rule, so f dashed of x, cos is my outside function, so I want to differentiate that first. So cos becomes negative sine x squared plus 5. And then I want to multiply by the derivative of the inner function, which is just 2x. And if I just write this in a slightly nicer way, negative 2x sine x squared plus 5. And then part G. Again, hopefully you're pausing the video, trying these first, and then just double checking with the solution.